All right, remote calculus, welcome to your antiderivatives quiz number 2 review. Here are the answers. So this is what I emailed to you right here. Remote calculus antiderivatives quiz number 2. It should say review. Quiz is in 10 days via Google Meet, 1:15 p.m. Evaluate each integral. You have 6 indefinite integrals and then 8 with bounds. That's called definite integral. So I've written on number 1. I'm going to go over here now. That is the original. X to the third minus 2x plus 5. There are no bounds, so I just find the regular general antiderivative. I add 1 to the power 4, I divide by 4. Minus, I add 1 to the power 2, I divide by 2. Plus, 5 becomes 5x plus c, and I simplify that as follows. A quarter x to the fourth minus x squared plus 5x plus c. That one's got a pretty easy answer. On 2 here, I have 2 on the outside. Again, this coefficient, which is applied to everything in here, if there was like a plus 3x, that 2 would also go to 3x. That's what I'm saying. It can be written on the inside or the outside here. So I take the derivative of what to get me secant? The derivative of secant squared. The derivative of tangent is secant squared. Okay, so the antiderivative of secant squared is tangent, and I attach the 2 plus the arbitrary constant c. All right, here on number 3, I take the derivative of what to get secant 2x tangent 2x? I take the derivative of secant to get, that is wrong, to get secant x tangent x. All right, that is right now. Now be careful. So when I take the antiderivative of secant 2x, tan 2x, first off, that 4 is going to come on down. It's going to be secant 2x. And then if I were taking the derivative of this, I would have to multiply by 2x instead, multiply by 1/2. So don't forget about that angle there. Plus c, which gives me 2 secant 2x plus c. If I took the derivative of 2 secant 2x, I would get 2 secant 2x tangent 2x times the derivative of 2x, which is 2. 2 times 2 gives you 4. Number 4, so cosine 2x minus 4 sine 3x. I take the derivative of what to get cosine, and that is sine. Sine 2x. Again, instead of multiplying by 2, I multiply by 1/2. I take the derivative of what to get negative sine. I take the derivative of positive cosine to get negative sine. That's why it's a positive 4. Cosine 3x, again, instead of multiplying by 3, which is what I would do if I'm taking the derivative, I divide by 3 or multiply by 1/3. 1/3 times 4, 4/3, 1/2 on the outside there, plus c. Those are the first 4. Number 5 here, the antiderivative of any e to the u is e to the u, and then I got to look at that u, and instead of multiplying by the derivative, I would divide or multiply by the reciprocal there. So the antiderivative of 2 through e to the 3x would be 2e to the 3x. Instead of multiplying by 3, which is the derivative of 3x, I multiply by 1/3. 2 times 1/3 is 2/3. Don't forget about that arbitrary constant c. I need to clean this up. 4 over x squared, or 3 over x squared is 3x to the negative second. Minus, this is 4 over x. Again, 4 over x is like 4 times 1 over x. Talked about this a bunch. The antiderivative of 1 over x is natural log x. There's a 4 on the outside. Here, with the x to the negative second, I add 1 to the power. It's actually negative 1. Then I divide by negative 1. X would go down south. 3 over negative 1 is a negative 3. Then I have plus c. Number 7. I got bounds here. Take the antiderivative. I go 1 power up, divide by the new power. I go 1 power up, divided by the new power. And go 1 power up, which should be x to the first, divide by that new power 1. All right, so I'm going to evaluate the antiderivative. Again, it's f of b minus f of a. That's a, that's b. Capital F is the antiderivative. I plug 2 into this antiderivative. 16, half of that is 8. 8/3. 8 minus, plugging in 1, it's easy, 1/2 minus 1/3 plus 4 Again, you can use the calculator. I am just matching them up here, though. That is 16 minus 4 is 12. Then I have 8/3 minus a negative 1/3. That's a negative 7/3. Then I'm subtracting a half. Well, that gets me 55 over 6. On 8, I made a boo-boo. I just started giving the answers. So 4 over x, that is, we need to change this to 1. The bound cannot be 0 to 3 because it's undefined. 0. Made a boo-boo. Can't find that antiderivative. Can't evaluate that integral. It's got to be able to find its antiderivative. So change that to 1. So this is, again, 4 times 1 over x. Antiderivative of 1 over x is natural log x. Don't forget about the 4, that coefficient right there. Evaluate it at 3, then evaluate it at 1. So 4 natural log 3 minus 4 natural log 1. Natural log 1 is 0. Again, type that in your calculator. Now, in Honors Algebra 2, you learned that number on the outside can be written as an exponent. That's the power rule. So you can say 4 natural log 3. That's a fine answer. Or natural log 81. All right. Let's keep rolling here. Number 9. I take the derivative of what to get 2 sine x? That would be negative 2 cosine x. As the derivative of cosine is negative sine. All right, then I'm going to evaluate it at pi over 2 and then 0. So I plug pi over 2 in for x. I plug 0 in for x. The reason I put plus here is because I would be subtracting a negative 2 cosine 0. So that's why I have a plus. Negative 2 cosine pi over 2. Cosine pi over 2 is 0. Plus, because I'm subtracting a negative 2 cosine 0. Cosine 0 is 1. 2 times 1 is 2. Number 9. That is number 9. Number 10. You got the 4 on the outside. I take the derivative of what to get cosine? I take the derivative of sine to get cosine. So you got that 4 on the outside. Sine 2x instead of multiplying by 2x, or multiplying by 2, which is what I would do if I were taking its derivative. I multiply by a half. 4 times a half is 2. 2 sine 2x. Plug in pi over 3, plug in 0. Now you're going to double pi thirds. If you plug pi thirds in for x, it gets doubled. 2 sine 2 pi thirds minus 2 sine 0. Sine of 0 is 0. Sine of 2 pi thirds is root 3 over 2. The 2's cancel. You're left with root 3. Number 11. Antiderivative of 3e to the u is 3e to the u. Instead of multiplying by 4, which is what I would do if I take the derivative, I multiply by a quarter. Now I have 3/4 e to the 4x. Evaluate at 1 minus its evaluation at negative 1. And it's just simply that. That is fine. I take the derivative of what to get secant squared. That is tangent. Don't forget about the 2 on the outside. Evaluate it at pi 6 and 0. So I have 2 tangent pi over 6 minus 2 tangent 0. Tangent of 0 is 0 because tangents, yes, it's opposite over adjacent. That's from geometry. It's also sine over cosine. All right, and sine of 0 is 0. So we need to know that sine 0 is 0, tangent of 0 is 0. All right, so I'm going to rewrite tangent pi over 6 as sine pi over 6 over cosine pi over 6. Sine pi over 6 is 1/2. Cosine pi over 6 is root 3 over 2. The 2's cancel. You have 1 over root 3 times 2. That puts 2 in the numerator, root 3 in the denominator. And 13. There is my function on the inside there. 2 over x minus 4 over x squared plus 3. I'm going to rewrite that a little bit. Again, I could have called this 2 times 1 over x. That antiderivative is this 2 natural log x. For the minus 4, x to the negative second, I add 1 to the power. I divide by that new power, which is now negative 1. I add x to 3, a negative. It's divided by a negative is a positive, so 4 over x. Plug 2 in for x, there, and there. Minus, I plug 1 in for x, there, and there. Natural log 1 is 0. That is 8 minus 7. That's how I got 1. 2 natural log 2. Again, this can be written as an exponent. You can call it natural log 4 or 2 natural log 2. Either of those answers is fine. And the last question we have here. 2e to the u its antiderivative would be 2e to the u. Instead of multiplying by a third, which is what I would do if I were taking the derivative, I'm going to divide by a third or multiply by 3. It gives me 6e to the 1/3 x. I'm going to plug 2 in for x. I'm going to plug 0 in for x. E to the 0 is 1. 1 times the -6 is -6. There it is. This is actually going to be your last quiz of the year. So this is the last quiz review. This is Yak Math Videos signing out.